Hello students, this video is for valence electrons. We're going to do a few problems from this practice worksheet on valence electrons, and before that just to review a little bit about what valence electrons are using this slide from your notes. So here we have a diagram of an atom of magnesium, and it shows the energy levels with its electrons. So we have 1s2, which are the 2 electrons there, 2s2, so now we're in the second energy level. It has both s electrons and p electrons for a total of 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the next energy level is the third energy level, and there we have 3s2, so there are just 2 electrons in the outermost energy level, which for magnesium is this third ring, the third energy level. And these are the valence electrons. Valence electrons are the electrons in the highest energy level. These ones on the inside are the core electrons. And since valence electrons are only the ones in the highest energy level, they're always just going to be s or p electrons. Okay, we will never have d or f as valence electrons. And that's because the d and f go into energy levels that are inside of the highest energy level. All right, so that'll make more sense when we go through the worksheet. We can also show valence electrons as dots around a chemical symbol when we're indicating the number of valence electrons that they have. And so we'll kind of do examples of this as well. Just keep in mind that we want to put 1 dot on each side before we double up, and we can only have a maximum of 2 electrons on each side. So you can kind of think about having these imaginary spaces around the symbol. And we'll practice doing that here. We will need our periodic table to answer these questions. I'm just going to do a few examples from this worksheet. We'll see how far we get. So starting with chlorine, for each of these we are given the element, we need to give the symbol. We'll add valence electrons for the dots. We need to write the valence electron configuration. Pay attention, this is just the valence configuration, not the full electron configuration. We need to give the number of valence electrons, what group and period the element is in, and what block it's in. So I'll do each of those for however many we get through. So we're going to start with chlorine here. The symbol for chlorine, if we first locate it on our periodic table, it is right here. So the symbol is Cl. And I'm going to answer this question next, which is how many valence electrons does it have? There's a really easy way to know this, and it is by using the number, the A numbering up here of the group number. So since chlorine is a halogen in group 7A, it means that it has 7 valence electrons, and so that actually means that this whole family will have 7 valence electrons. So valence electrons are 7, and now that I know that, I'm going to go back here and draw in those valence electrons. So remember, we need to add 1 in each before we double up. So 1, 2, 3, 4. Now I can go back and double up. 5, 6, 7. It doesn't matter where you start, but it's kind of a good idea to just go in a clockwise or counterclockwise position, and that gives us our 7 valence electrons. To write the valence configuration, remember, so we have chlorine here, it's only going to be the s and p electrons. So remember that this is the p block and this is the s block. So if we're talking about chlorine, all of the original electrons from the 1s and the 2s and the 2p, those are core electrons. Chlorine is in the third period, so we know we're going to have these 3s electrons. So we'll start with 3s2, and then we're in the 3p section, and we go to 3p, 1, 2, 3, 4, 5 to get to chlorine. Okay, so the valence electrons, it's just 3s2, 3p5. The 1s2, 2s2, 2p6, those are core electrons. They're in lower energy levels, so they don't count towards valence electrons. And this makes sense because if we take the 2 electrons there and the 5 there, that gives us a total of 7 valence electrons, which matches how many we initially wrote down. And we've kind of already answered this, but the group number for chlorine is 17. So this is the regular numbering, not the A numbering, 17. And then the period is period 3. And then we also mentioned this. Which block is it in? This whole block here is the P block. Okay, so chlorine is in the P block. That's the first one. Okay, let's move on to calcium here. The symbol for calcium, we have Ca. Okay, the number of valence electrons, since it is here, it's in group 2A, so it has 2 valence electrons. And when we write the configuration, it's in the 4s, so it's going to be 4s2. Okay, because this would be 4s1, this is 4s2. Remember, it's only the S and P in the highest energy level. And then the group number, since it's 2A, that's also group 2. And the period number, we already kind of looked at that. It's period 4. Okay, so this is, periods go this way. 2, 3, 4. So this is period 4. And this time, calcium, this is in the S block. This region here is the S block. Okay. We'll do a couple more, pretty good on time here. So we need to add our valence electrons, 2 valence electrons. So we'll do that. We'll try to go quickly through a couple more. So iodine, another halogen is right here, it's I. Since it is a halogen, it's also in group 7A, which means it also has 7 valence electrons like chlorine. So I'll put the 7 there, and then I'll add my 7 dots. Okay. The valence configuration for iodine, since it's here, we go here and start with 5s2. And this is a place to be careful here. After the 5s, we go into the D block, but remember that the D block is 1 energy level behind. So this is actually 4d1, 4d2, 4d3. So since they're in the 4th energy level, they are not valence electrons, because remember the S is already in the 5th energy level. So now we're going back to 4d. We can ignore those until we come to 5p, and then we go 5p, 1, 2, 3, 4, 5. So it's going to be 5p5. So one way you can kind of check this is to make sure that these numbers here, the energy level, those should only be one number. So since we have 5s here, we should not have any other energy levels there. Like here we have 3 and 3, that's okay. Here we have 4, here we have 5 and 5. Okay, and the 2 plus 5 electrons add up to the 7 valence electrons we initially said. Okay. Group, it is a halogen, so it's group 17. Period, it is the 5th period, and it is in the P block. All right, one more tricky one. We're gonna skip down to iron. Okay, iron is here. It is Fe. Okay, iron's a little tricky. The number of valence electrons that iron has, let's answer a few other questions first. It is in group 8, so we can write that. Oh, sorry, I wrote that in the wrong spot. And then period 4. Don't make the same mistake I did. All right, and the block. This is kind of the tricky part that we're going to talk about. The block here, this is the D block. So there's something we need to remember about the D block that I mentioned already. The D block is an energy level behind. So even though iron is in the D block, these electrons right here, they're in 3D. But notice that the S is in 4s. So these electrons right here aren't actually valence electrons. The S ones are. Remember we said S and P electrons are valence. But since these are D electrons, they are not considered valence electrons because they're in a lower energy level. So that means that all of these transition metals, transition elements in the D block, they all have the same number of valence electrons, and it's only those S electrons that are in the highest energy level. So they all have 2 valence electrons. All of these D block elements, okay, because D electrons are not valence, only the S and the P, and they haven't reached the P block yet, so just these S electrons. So that means that the valence electrons for iron are these 4s2 electrons. Okay, it's pretty tricky. So be careful, and now we can say 1, 2. Be careful with those transition metals in the D block. They only have 2 valence electrons. That's one I wanted to go over. I think you have enough tools now to get through the rest of the worksheet. Good luck.